Hello everyone. This is Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. Today we are going to discuss about CPU scheduling, uh, one problem. So this is the problem statement. Consider three processes all arriving at time zero with a total execution time of 10, 20, and 30 units respectively. Each process spends the first 20% of execution time during IO, the next 70% of time during computation, and the last 10% of time doing IO again. So the operating system uses the shortest remaining computing time first scheduling algorithm and schedules a new process either when running the process gets blocked on IO or when running the process finishes its compute burst. Assume that all IO operations can be overlapped as much as possible. For what percentage of does the CPU remain idle? This is the problem. Okay, I will give that solution. Right. Generally, what they given means, but there are totally three process, process one, process two, process three. That's P1, P2, P3. And the execution time of all three processes, but P1 is 10 units, P2 is 20 units, and P3 is 30 units respectively. And each process spends what the first 20% of execution time during the IO. So for input output operations, first 20% of time will be spent, and the next 70% time will be allocated for CPU computations, and the last 10% in IO. And what is the algorithm? And the system uses shortest remaining compute time first. That is a SRCF scheduling algorithm. Okay, now let's break down the execution pattern and solve step by step to calculate the CPU idle time percentage. So what is the step one? The step one is what? I calculate compute time and IO time for each process. So this is the table, total burst time, IO burst, CPU burst, and IO burst. There are three processes, P1, P2, P3. So what is the execution time of P1? 10 units. What is the execution time of P2? 20 units. And what is the execution time of P3? 30 units. So this is called what? Total time. Okay. And total burst time or total execution time for all three processes. The second column, first 20 percentage will be allocated for what? IO operations. Okay, that already I mentioned in the problem. So 20 percentage means what? The total execution time is 10 now. The 20 percentage is what? 2. So the IO burst is 2 for process P1, and the total execution time of P2 is what? 20. So in this 20 percentage means what? 2 plus 2, 4. So the IO burst time for process P2 is 4, and for process P3, already the execution time is 30. From that execution time, 20 percentage of execution time will be allocated for IO burst. So in this 30, the 20 percentage is what? 6. So I hope you understand that first column and second column. The first column which describe the total execution time of all three process, 10, 20, 30 units respectively. And the second column IO burst. So this is what in the problem itself they have mentioned what 20 percentage of time spent for IO process. So with respect to execution time, we have to calculate the 20 percentage of execution time for process P1, 2 for process P2, 4 for process P3, 6. So 20 percentage of execution time. Then third one is what? CPU burst time. So what is the CPU burst time? In the problem itself, they have given what? 70 percentage of time. So 70 percentage in CPU computation. So what is the 70 percentage in total execution time? The total execution time is 10. So 70 percentage means what? 7. So the CPU computation time 7 for process P1. And for process P2, already the execution time is 20. So the 70 percentage of execution time is what? 7 into 2, 14. So CPU burst time for process P2 is 14. And the CPU burst time for process P3, the process P3 execution time is 30. From 30, the 70 percentage means what? 7 into 3, 21. So 21 computation time, CPU computation time for process P3. I hope you understand this concept. And the last column is what? Again, IO burst. So the IO burst is what? The last 10 percentage will be allocated for the IO burst. So with respect to everything will be considered based on that execution time. With respect to execution time for process P1, execution time is 10. So 10 percentage of 10 means what? 1. So the IO burst, the last column is what? 1. Execution time 20 for process P2. From 20, the 10 percentage is what? 2. So IO, last 10 percentage of IO burst for process P2 equal to 2. And for process P3, total execution time is 30. So the 10% of total execution time is 3. So the last IO burst for process P3 is 3. I hope you understand this concept, right? So the P1 execution time is what? 7 with respect to that CPU computation time. For P2, 14 units, and for P3, 21 units. So, and they become eligible for computer after the first IO. This is what step 1. And what is called step 2, what is each process becomes ready for computation. So, the process compute ready at P1 for 2, P2 for 4, and P3 for 6. So similarly, we have to calculate that scheduling shortest remaining computer time. Okay, so we have to refer that Gantt chart. So the next one, I hope you understand this table. Okay, we will move on to the next concept. This is what scheduling algorithm. So shortest remaining time first. So the P1 start at 2 only. So the first initially 0 to 2, all processors are doing input output operation. So CPU is ideal for 2 units. That's why in the chart I have mentioned that the black color. In this period, the CPU doesn't do any operations. So it is an ideal condition because all the processors are doing for IO operation. So CPU is ideal for 2 units. And at time T2, the P1 is ready. So what is the CPU execution time burst time? 7 units. So 7 plus 2, 9. So the P1 will complete at the time 9. And what is the P2? P2 actually at time P4, P2 will become ready. But shortest remaining time first only. So the compared to remaining time is what? P1 is only remaining time. So P1 will be completed. So when it is completed at time 9, P1 will be completed. So exactly the P2 will be started after completing the P1 process. So the P1, P2 will start 9. So what is the CPU burst time? 14. So 14 plus 9, 23. So the P2 will end at time 23. And at the same time, the P3 becomes ready. So what is the P3 becomes? Actually, P3 is what? 6 only. But what is the shortest remaining time? P2 will be completed. So the priority goes to for process P2, and P3 will start at 23. What is the computation time of P3? 21. You refer that previous table, right? For your convenient time. The previous table is what? A CPU burst time for P1 7. So it start with the 2. 7 plus 2, 9. The P1 end at 9. And the P2 process time is what? CPU burst time equal to 14. So it start with 9. 9 end at 14 plus 9, 23. And the CPU burst time for P3 21. The This is what shortest remaining time first. So yeah, after completing P2, then the P3 will start at 23. The next 21 units will be allocated for P3. So 23 plus 21, 44. At time 44, the P3 process will be completed. Then the remaining 3 units will be idle. So the CPU doesn't do anything because all 3 process completing the task. So that is idle. And what is the problem in part? For what percentage of does the CPU remain idle? So how many percentage of the CPU remains idle? Starting 2 cycles and the last 3 cycles. So 2 plus 3, 5 out of 47. So the percentage of CPU remains idle, 5 divided by 47 into 100. That is nothing but what? 10.638 percentage. I hope you understand this concept. Thank you.